We are solving two problems from ray optics. First, let me solve this small question, NEET 2017. It says, a beam of light from a source L incident normally on a plane mirror fixed at a distance x from the source. So, if you draw the diagram for that, this is a plane mirror whose back is coated with a color. There is a source L who is at a distance x from the source. The beam is reflected back as a spot on a scale placed just above the source L. So, this is the incident light. It reflects back because the angle of incidence is 0. So, the light travels back the same distance x and forms an image on the scale. So, this is the scale, that what he is saying. So, here itself there is an image is formed. Now, what he is saying is, when a mirror is rotated through a small angle theta, so the mirror is not there now, is now in a new place, like I am showing with red color. I have drawn though like a large angle, but he said the angle is small. You know, when the mirror turns an angle theta, its image turns by an angle 2 theta. So, the image formed is not at the same place, rather it forms at a different place. Image turns by an angle 2 theta, that is the standard rule. The spot of the light is found to move through a distance y on the scale. That means on this scale it has moved from here to a place where this distance is given as y. So, what is the rule that we have used is, if mirror turns angle theta, its image turns by angle 2 theta. In fact, I have proved this very much in detail with the diagram video. Please find that video in the playlist of ray optics. Now, you can see there is a right angle triangle formed here. I can write tan 2 theta as y by x. As theta is small or 2 theta is small, tan 2 theta or sin 2 theta is close to 2 theta. That implies, in the place of tan 2 theta I can write 2 theta. That implies theta equal to y by 2x. That is the answer for the problem. That is how we have to solve that problem. Now, let us have a look at this question, NEET 2016 question. Match the corresponding entities of 1 and 2 as where M is the magnification produced by a mirror. I will first focus on this convex mirror and tell you what happens with a convex mirror. Let me explain first with a convex mirror. What happens to a convex mirror image? Let me explain. So, let me draw a quick diagram of a convex mirror. This is what do you mean by a convex mirror whose inside is coated with some color. This is the convex mirror. Let us say you have kept your object here, somewhere at a distance u. Light falls on the mirror like this. All the distances are measured from the center of the mirror, pole of the mirror, this way. So, here your u is measured against the direction of the light. As per the sign convention, when the distance is measured against the direction of incident light, that shall be treated like negative. So, here u is negative. Let me draw a few more light rays and see and tell you what happens. This is one more light ray. This is one more light ray. It is very clear that these light rays will diverge from here. They go this way. So, definitely they are not meeting on the left side of the mirror. What do they ever happen is, our eye extend these light rays further and find that their image is formed somewhere here, image. So, the distance of the image is again from the center to this is v. If you notice, you are measuring from here to here in this direction, and that is in the direction of the incident light itself. So this V is positive. So you might have noticed definitely one thing, this V is not formed really, it was formed virtually. Our eye has extended the light rays. So the first thing that you need to understand is image of convex mirror is virtual. If you write the formula for the magnification, magnification is minus V by U. Minus V is plus V. As I told, U is minus U. That minus of minus becomes plus. So magnification is positive for a convex mirror. One more thing is, the image formed here is always diminished. That means size of the image is smaller than the size of the object. So few things were noticed with a convex mirror. That image is virtual, magnification is positive, image is diminished means magnification is less than 1. Look at the options. Magnification is positive and less than 1. That's only option D, that what we have. So option D shall have a linked with convex mirror, as the image is virtual image. So option D shall have A and D, that's only correct answer. See here, option D is having C and D. C is a real image, which is not correct for a convex mirror. So option A is wrong. Look at option B. Option D has B and C. B is concave mirror. We are talking about option D, who is positive magnification. For a concave mirror, magnification could be positive or negative. And C is a real image. This D, positive magnification, means virtual image. So it's not a real image. So option A and B are definitely wrong. That can be checked with D option, right? So they two are definitely ruled out. So as for the understanding, convex mirror has positive magnification less than 1 because it's a diminished image. So for this, who is positive, there shall be virtual image and convex mirror A and D, that are there only in options A and D, C and D. So one answer of the C and D is correct. Definitely A and B are wrong. Further, who is correct in that C and D? To identify that, we can solve further and take one more option, right? Let us take the first option itself. Anything is fine. Option 1. Magnification is negative, right? That means minus V by U equal to minus 2 as it is given. That implies V equal to 2U. So one thing is clear, both V and U are on the same side. That can happen with a concave mirror. Concave mirror can have a negative magnification or a positive magnification. Let me draw a diagram of a concave mirror and show you what is happening. So this is a concave mirror. This is U measured from center. This is V. Image is formed equal to 2U. This is the direction of incident light. So U is negative because it's measured against the incident light. V is also negative because that is also measured against the direction of incident light. Then magnification is minus V by U, our integral formula. Minus V means minus V because it's against the direction of light. U means minus U because that is also against the direction of the light. This minus minus and will cancel. This becomes minus V by U. So magnification could be negative for a concave mirror. It could be positive too when the image is formed on the other side. right? So what we can understand here is magnification is -2 means it could be a concave mirror. Definitely image formed is real. Our eyes have not extended like this, rather it is originally formed on the eyes. So it is a concave mirror and real image. So for this first option A, you shall have an options of concave mirror B, real image C. So but for the third case, you see what is there? A is C and D. C is real, D is virtual. A image cannot be both real and virtual. So this option itself is wrong. So option C is wrong. Option D is right. I need not worry and explain the other parts of it. You can go through the videos of the playlist to understand the other parts, other options, right? I have discussed them very much in detail. This is how we have to understand mirrors, right? I hope this is not looking like lengthy and tough for you. Just go through the basics, see the natural sign conventions, so that this concepts becomes easy. Probably you need to see the video once again in a silent and calm environment, and if you have still something to ask, you can just ask at the end of the video. Thank you for watching.